Hello and welcome to SigmaXL video tutorials. In this video, we demonstrate the use of the Advanced Multiple Regression tool in SigmaXL. In a previous video using basic multiple regression, we analyzed the relationship of overall satisfaction versus responsive to calls, ease of communications, and customer type using customer data. Overall satisfaction is on a 1 to 5 scale, where 1 is very dissatisfied and 5 is very satisfied. Now, we'll use Advanced Multiple Regression to continue the analysis of overall satisfaction. We will standardize the continuous predictors, include 2A interactions, discuss the prediction equation with continuous and categorical predictors, assess R-square predicted and R-square k-fold for validation, review the parameter estimates and ANOVA for predictors report with Pareto of percent contribution and Pareto of standardized effects, and cover the items in this list. To begin, open customerdata.xlsx, click SigmaXL, Statistical Tools, Advanced Multiple Regression, Fit Multiple Regression Model. Click Use Entire Data Table and click Next. Select Overall Satisfaction and click Numeric Response Y. Select Responsive to Calls and Ease of Communications and click Continuous Predictors X. Select Customer Type and click Categorical Predictors X. Test with Hold Sample ID will not be used at this time. See the SigmaXL workbook for an example on how to use this option. Check Standardize Continuous Predictors with the default Standardize option. Subtract the mean and divide by the standard deviation. If you're planning to include interaction terms in the model, always ensure that Standardize Continuous Predictors is checked. This has two benefits. The predictors are scaled to the same units so coefficients can be meaningfully compared, and it dramatically reduces the multicollinearity VIF scores. Now, check Display Regression Equation with unstandardized coefficients. This format will be easier to interpret. We'll use the default coding for categorical predictors 1, 0. This is the standard dummy coding used for categorical predictors, with the hidden reference value being the first alphanumerically sorted level. Use the default confidence level of 95%. Regular residual plots are checked by default. Check main effects plots and interaction plots. Note that main effects plots and interaction plots use fitted means, not data means. Leave Box-Cox Transformation unchecked for now. This will be used later. Click Advanced Options. Assume constant variance, no autocorrelation is checked. Use of this option will be discussed later in this video. Term ANOVA sum of squares with adjusted type 3 is checked and will provide a detailed ANOVA table for continuous and categorical predictors. R-square Pareto chart is checked and will display a Pareto chart of term R-square values. Standardize effect Pareto chart is also checked, which displays a Pareto chart of term T values. Check k-fold cross-validation with default number of folds k equals 10 and seed equals 1, 2, 3, 4. In k-fold cross-validation, the data is randomly partitioned into k approximately equal subsets, and this will provide a 10-fold cross-validation R-square value. Saturated model pseudo-standard error, lengths PSE, is checked by default, but it is not used here, as this is only applicable to saturated models with 0 error degrees of freedom. Keep Stepwise best subsets regression unchecked for now. This will be used later. Click OK. Click Next. Using Term Generator, select Main Effects plus 2A interactions. Click Select All. We're adding the 3 possible 2A interactions. Note that the 3 interaction terms are continuous by continuous, continuous by categorical, and continuous by categorical. Click OK. The Advanced Multiple Regression report is shown. The regression equation with unstandardized, uncoded coefficients is displayed at the top of the report. Note blanks and special characters in the predictor names are converted to underscores, so they are legal Excel range names. For categorical predictors, if statements are used, but exclude the hidden reference level, which in this case is customer type 1. These coefficients do not match those given in the parameter estimates table, since the table values are standardized. If consistency is desired, one can always rerun the analysis and uncheck display regression equation with unstandardized coefficients, but we will not do that here. In the model summary table, the R-square of 92.88% indicates that the percent variation explained by the model is quite good. R-square adjusted, which includes a penalty for the number of terms in the model, equals 92.17%, is also good. Standard deviation is 0.2190. The addition of the three interaction terms results in an improvement over the previous analysis we demonstrated in the basic multiple regression video, where R-square was equal to 90.58%. R-square adjusted was equal to 90.18%, and the standard deviation was 0.2452. R-square predicted equals 89.88%, also known as the leave one out cross-validation, indicates how well a regression model predicts responses for new observations, and is typically less than R-square adjusted. This is also good. The model information table summarizes the selected options for the model, so here we can see for continuous predictors, we're using standardization, subtract the mean and divide by the standard deviation, and categorical coding of 1, 0. The information criteria and validation table is also shown to the right. The information criteria AICc and BIC are reported here, but are used for model comparison. We will revisit these when we do model refinement with forward selection. R-square tenfold equals 89.54%. The R-square from k-fold cross-validation is good. It is approximately the same as the R-square predicted. Standard deviation tenfold equals 0.2518. While slightly higher than standard deviation, as expected, it is also good. Repeating the analysis with a different k and or seed will produce slightly different results for R-square and s-k-fold. The other tables provided in the report are the parameter estimates Standardize table, the analysis of variance for model table, the analysis of variance for predictors adjusted type 3 table, the Pareto of term R-square, and the Pareto of standardized effects. The p-values for continuous predictors are the same in the parameter estimates and ANOVA for predictors tables. For categorical predictors and interactions involving a categorical predictor, the parameter estimates table gives a coefficient and p-value for each level, excluding the hidden reference level. The ANOVA for predictors table gives an overall p-value for each of the categorical terms. Note that the degrees of freedom for each of these is equal to 2. Customer type is insignificant as a main effect, but is potentially significant in the ease of communications by customer type interaction, with a term p-value of 0.0738. The responsive to calls by customer type interaction is not significant, with a term p-value of 0.39. However, in this example, we will not use p-values to decide what terms are removed and what terms remain in the model. Rather, model refinement will be based on the criteria R-square predicted and AICc. The Pareto charts and Pareto legend are displayed to the right of the report. From the Pareto legend, we can see that x1 is equal to responsive to calls, x2 is equal to ease of communications, and x3 is equal to customer type. The Pareto chart of term R-square and Pareto chart of standardized effects graphically present the information given in the predictor ANOVA table and show the responsive to calls, ease of communications, and responsive to calls by ease of communications are the dominant contributors to the variability and overall satisfaction. Note that the term R-square values do not add up to an R-square of 92.88%, since these are type 3 adjusted sum of squares, but they're still useful to assess relative contribution. If we included type 1 sequential sum of squares, the term R-square values would add up to 92.88%, but have the disadvantage that the individual term R-square values depend on model order, whereas type 3 do not. If the predictors are orthogonal from a designed experiment, then type 3 and type 1 are the same. The variance inflation factor, or VIF scores, are all less than 5, so they're acceptable, but they're higher than those we saw in the previous video using basic multiple regression. So this is something that we'll want to keep our eye on as we progress with model refinement. The Durbin-Watson for autocorrelation and residuals table contains the Durbin-Watson, or DW test, and is used to detect the presence of positive or negative autocorrelation in the residuals at lag 1. If either p-value is less than 0.05, then there is significant autocorrelation. In this example, we do see significant positive autocorrelation, which is a problem because it violates the regression assumption of independence. This may also be evident in the plot of residuals versus observation order when we demonstrate residual plots later in this video. If the Durbin-Watson test still shows significant autocorrelation after model refinement, the model can be refitted with assumed constant variance, no AC unchecked, and SigmaXL will apply the Nui-West robust standard errors with autocorrelation. For more details, see the SigmaXL workbook. The Brush-Pagan test for constant variance is also displayed at the bottom of the report. There are two versions of the Brush-Pagan test for constant variance, normal and Cohnker-Studentized robust. SigmaXL applies an Anderson-Darling normality test to the residuals in order to automatically select which version to use. If the ADP value is less than 0.05, Cohnker-Studentized robust is used. The report includes the test for all terms and for individual predictors. All terms denotes that all terms are in the model. This should be used to describe whether or not to take corrective action. The individual predictor terms are evaluated one at a time and provide supplementary information for diagnostic purposes. Note that this should always be used in conjunction with an examination of the residual plots. Here we see that the all terms test is not significant, but the responsive to calls by ease of communications interaction is significant with a p-value of less than 0.05. As we noted with the Durbin-Watson test, this status may change with model refinement. Now I'll demonstrate the predicted response calculator. Enter 5 for responsive to calls and ease of communications. Select Customer Type 2 from the drop-down list to predict overall satisfaction. The predicted response is 5.02. The prediction will include the 95% confidence interval for the long-term mean and the 95% prediction interval for the individual values. Now, we'll review the residuals. Click on the sheet MREG1 Residuals. Regular residual plots display the raw residuals, y minus y hat, the unexplained variation from the regression model, with a histogram, normal probability plot, residuals versus data order, residuals versus predicted values, residuals versus continuous predictors, and residuals versus categorical predictors. We expect to see the residuals normally distributed with no obvious patterns in the graphs. This is not the case here, but they are better than the residual plots in the previous video using basic multiple regression, which showed a strong trend in the residuals versus predicted values. The table of residuals, standardized, studentized, deleted t, Cook's distance, influence, leverage, and defits are given to the left of the residual plots. Standardized residuals are the residuals divided by an estimate of its standard deviation. This makes it easier to detect outliers. Standardized residuals greater than 3 and less than -3 are considered outliers and highlighted in red. Using Excel's filter by font color, we can see that the standardized residuals for observations 43, 66, and 76 are highlighted outliers. Outliers should be examined for measurement errors or possible assignable causes, but we will not do that in this video. Clear the filter to view the residual plots again. See the SigmaXL workbook for further details on studentized, deleted t residuals, Cook's distance, influence, leverage, and defits. The table to the right of the residual plots is the stored model design matrix with the coded categorical predictors and residuals. These are provided to manually create additional residual plots, but we will not demonstrate that in this video. Click on the sheet MREG1 Plots. The main effects plots and interaction plots for overall satisfaction are shown. These are based on fitted means as predicted by the model, not data means. Here we see that responsive to calls has the steepest slope followed by ease of communications. Customer type does not appear to be an important factor, however, we also need to consider the interaction plots. Here we can clearly see a moderate interaction effect with the different slopes in responsive to calls by ease of communications. That is, the effect that responsive to calls has on overall satisfaction depends on the value of ease of communications. Similarly, the effect that ease of communications has on overall satisfaction depends on the value of responsive to calls. There also appears to be a slight interaction effect with the different slopes in customer type by ease of communications. These plots should always be used in conjunction with the parameter estimates table and Pareto charts to determine significance. Note that if an interaction term is not in the model, the interaction plot is still displayed, but it is shaded gray. Now, I'll rerun the analysis using stepwise forward selection using the criterion R² predicted. Click Recall SigmaXL dialog or press F3. In the Advanced Multiple Regression dialog, click Advanced Options. Check Stepwise Best Subsets Regression, select Forward Selection, and Criterion R² predicted. Hierarchical is checked by default. Click OK on the Advanced Multiple Regression Options dialog. Click Next. Click OK. Click on the sheet MREG2 Report. Forward selection identifies the model at step 3, denoted with a double asterisk, and highlighted in yellow as having the largest R² predicted value of 90.35%. R² predicted with a double asterisk denotes that this is the criterion used to select the final model. Note that while the model at step 4 has a slightly higher R² predicted, it is not selected because it does not include customer type, which is needed for the model to be hierarchical. When customer type is added at step 5, the R² predicted value is less than that of step 3. Mode can be add, add H, or remove. Add H denotes a predictor being added for hierarchy. Remove is not applicable for forward selection. Number of predictors is the number of continuous or categorical predictors in the model, excluding the constant. Model terms is the number of columns in the model design matrix, including the constant and coded columns for the categorical predictors. This is the value used by all of the metrics. P is the p-value for the predictor. This is the p-value for the term at that particular step and is subject to change when other terms are added. P-values are used for model selection, that is stopping rule, only when alpha to enter has been specified. Since we selected criterion, they are not used for model selection, but the decision of what term to consider at a particular step is still based on the p-value. S is the model standard deviation, or root mean square error, at that step. R² is the R², that is, the percent variation in response that is explained by the model at that step. R² adjusted is the R² adjusted for the model at that step. The model at step 5 has the maximum R² adjusted value of 92.18%. R² predicted is the R² predicted for the model at that step. For details on these metrics, please see the SigmaXL workbook appendix for Advanced Multiple Regression. In conclusion, we can use either step 3 or step 5 as our final model, but we will proceed with the simpler model at step 3. This model can be viewed by scrolling to the right. Click on the sheet MREG2 Model Overall. In the model summary table, we can see that R² is now 91.76% and R² adjusted is now 91.5%. These have been reduced slightly versus the full model, which had an R² of 92.88% and an R² adjusted of 92.17%. S is now 0.2281, which is slightly higher than the full model S of 0.219. However, R² predicted is now 90.35%, which is an improvement over the R² predicted of 89.88% for the full model. And we've also made interpretation much easier by simplifying the model and removing all terms with customer type. The model information table summarizes the selected options for the model, showing that stepwise method is forward selection, hierarchical, and the criterion is max R² predicted. The information criterion validation table shows an R² tenfold of 90.07%, which is an improvement over the full model R² tenfold of 89.54%. S tenfold equals 0.2453, which is slightly less than the full model S tenfold of 0.2518. In this model, we can see that the continuous predictors responsive to calls, ease of communications, and the interaction responsive to calls by ease of communications all show as clearly significant. The variance inflation factor, or VIF scores, have been reduced from the full model. For example, ease of communications VIF equals 1.19 versus the full model VIF equals 4.01. The Pareto chart of term R-square and Pareto chart of standard effects graphically present the information given in the predictor ANOVA table and show that main effects responsive to calls, ease of communications are the dominant contributors to the variability in overall satisfaction. The interaction term responsive to calls by ease of communications is a smaller contributor, but is still significant. The Durbin-Watson test for autocorrelation and residuals table no longer shows significant positive or negative autocorrelation, which is a change from the Durbin-Watson test for the full model. This demonstrates that the residual diagnostics can change as the model changes with model refinement. In the Brush-Pagan test for constant variance, we now see that the all terms test is significant and that the responsive to calls by ease of communications interaction is also significant. Now, I'll refit the model using Box-Cox Transformation in order to deal with this violation of the regression assumption of constant variance. Click Recall Last Dialog, or press F3. Since we no longer want customer type in the model, select Customer Type and click Remove. Uncheck Display Regression Equation with Unstandardized Coefficients. Check Box-Cox Transformation with Rounded Lambda. Click Advanced Options. Uncheck Stepwise Best Subsets Regression. Note that Box-Cox Transformation can be used with Stepwise Best Subsets Regression, but here we want to manually specify the model. Click OK. Click Next. Select Main Effects plus 2A Interactions. Click Select All. Click OK. The Advanced Multiple Regression report is given for the revised model. In the model information table, the Box-Cox transformation lambda value is equal to 2, which means that we're squaring the overall satisfaction response values. Note that the parameter estimates, model summary, information criterion validation, test statistics, and residuals are for the Box-Cox transformed response. The main effects and interaction plots, predicted response calculator, optimize, and contour surface plots all use an inverse transformation to return to the original units. The top of the report now displays a regression equation with standardized coefficients and inverse transformation by raising to the power of 1/2 for the square root. The model summary table is shown. R-square, R-square adjusted, and R-square predicted have all increased over the previous untransformed model. Note that the standard deviation of 1.5567 is reported for the Box-Cox transformed response, so cannot be compared to the untransformed standard deviation of 0.2281, but the R-square statistics can be compared. The information criterion validation table is also shown. R-square tenfold has increased over the previous untransformed model. As mentioned, the S10-fold of 1.6228 is reported for the Box-Cox transformed response, so it also cannot be compared to the untransformed S10-fold of 0.2453, but the R-square tenfold statistics can be compared. The parameter estimate standardize, analysis of variance for model, analysis of variance for predictors, adjusted type 3, Pareto of term R-square, and Pareto of standardized effects are shown. The interaction responsive to calls by customer type has increased in R-square % and standardized effect versus the untransformed model, so is a stronger interaction effect. The DW values in the Durbin-Watson test for autocorrelation and residuals table have changed slightly from the untransformed model, but still show no significant autocorrelation. The Brush-Pagan test for constant variance is also shown. This is a dramatic change from the Brush-Pagan test for constant variance. The all terms test now shows as insignificant. As well, the responsive to calls by ease of communications interaction is insignificant. The use of Box-Cox transformation has eliminated the problem of non-constant variance in the model. Had that not been the case, we would have then proceeded to refit the model with assumed constant variance, no AC unchecked. Click on sheet MREG3 plots. The main effects plots and interaction plots for overall satisfaction are shown. These are based on the fitted means as predicted by the model. Here we see that responsive to calls has the steepest slope, But now there is some curvature due to the Box-Cox transformation. We also see the curvature due to the Box-Cox transformation in the interaction plots. Here we can clearly see a strong interaction effect with the different slopes in responsive to calls by ease of communications. That is, the effect that responsive to calls has on overall satisfaction depends on the value of ease of communications. Similarly, the effect that ease of communications has on overall satisfaction depends on the value of responsive to calls. Click on sheet MREG3 model. Scroll to the predicted response calculator. Enter responsive to calls and ease of communications equals 5 to predict overall satisfaction with a 95% confidence interval for the long-term mean and 95% prediction interval for individual values. Note that the formula in cell L14 is an Excel formula raised to the power of 1/2. Since we are applying an inverse transformation to the Box-Cox transform prediction, the confidence and prediction intervals are not symmetric. Next, we'll use SigmaXL's built-in optimizer. Scroll to view the optimized options. Here we can constrain the continuous predictors, and if there was a categorical predictor, specify a level to use for optimization. If a continuous predictor is integer, change the integer value from 0 to 1. The optimizer will return only integer values for that predictor. For demonstration purposes, we will leave the optimized option settings as is. Scroll back to view the goal setting and optimize button. Select goal equals maximize. The optimizer uses multi-start Nelder-Mead simplex to solve for the desired response goal with given constraints. For more information, see the SigmaXL workbook appendix for single response optimization. Click Optimize. Click Yes to paste the values. This confirms that our manual settings were correct to provide maximum overall satisfaction. Next, we will create a contour surface plot. Click the Contour Surface Plots button. Note this button will not be available if there are fewer than 2 continuous predictors. A new sheet called MREG3 Contour displays the plots. The curvature in the response is due to the two-way interactions and the Box-Cox transformation. We clearly see that maximizing both responsive to calls and ease of communications is necessary to maximize overall satisfaction. The table with the hold values provides the values used to hold a predictor constant if it is not in the plot. This becomes useful if there are more than 2 predictors in the model. Next, we'll demonstrate the use of best subsets regression. Click Recall Last Dialog or press F3. Select Customer Type and click Categorical Predictors X. Uncheck Box-Cox Transformation so that we can compare the best subsets report to the earlier forward selection report. Uncheck Residual Plots, Main Effects, and Interaction Plots, as we will not revisit these. Click Advanced Options. Check Stepwise Best Subsets Regression. Select Best Subsets with the default value of 1 for each number of predictors. Max time in seconds equals 300, and Criterion as AICc. Hierarchical is checked by default. Click OK. Click Next. Select Main Effects and Two-Way Interactions. Click Select All. Click OK. Click on the sheet MREG4 Report. This is similar to the forward selection report, but instead of steps, shows the best model that minimizes the criterion, AICc, for each number of predictors. The double asterisks and yellow highlight show the selected overall best model. Model 5 has the minimum AICc. Scroll to the right as we did with the forward stepwise report to view the model. For comparison, Model 3 has the minimum BIC. Note that best subsets evaluates only models that satisfy hierarchy. Those that do not are not considered. R-square predicted and R-square tenfold cannot be specified as criterion in best subsets due to their computation times, but they are reported here. Mode and P given in the forward selection report are not shown because they are not applicable to best subsets. This concludes our demonstration of our Advanced Multiple Regression tool in SigmaXL. To recap, these are the topics explored in this video. By using these, you'll be able to build better regression models. For more videos, visit www.sigmaxl.com or join us on YouTube. Thank you for watching.